Okay, moving on to the derivatives for exponential functions. Let's begin with the parent of all exponential functions, which is e to the x. This one here is quite elegant because the derivative of e to the x is also e to the x. It turns out that the rules for exponential functions, at least when the base is a constant, have an origin with e to the x, and you can adapt based on that to get to the more general forms. For example, if the base wasn't e and there's some other quantity like a, the derivative is also going to have this copying feature, a to the x, but you're going to correct it by a logarithm, a natural logarithm of the base a. What if you have e to the x, but now the exponent is a function of x? In this case, we apply a chain rule. So you still copy the exponential and then multiply by the derivative of whatever the exponent is. If we add the general base a and we add the chain rule to the exponent, we have the most general for exponential functions. In this case, that's a to the f of x. Its derivative consists of three parts. We have copying the exponential, taking the chain rule or the derivative of the exponent, and then finally multiplying by the natural logarithm of that base. Let's try several examples practicing the rules using these various exponential forms, beginning with 5 to the x. So in this case, we have a base that is not e, so we're going to apply a correction, which is the natural logarithm. So that's 5 to the x by ln 5. And that's the final answer. Okay, let's try another example, in this case where we have a chain rule. In this case, the exponent is simply not just x, but a function of x. How do we find the derivative? We just copy the exponential and multiply by the derivative of the exponent, which in this case is 11. Now, for aesthetic reasons, you could put the 11 in the front there. Just looks a little bit nicer, but completely fine to leave it in the earlier step. Moving on to the next example, we have the most general of the forms, at least from the cover slides, which is an arbitrary base, or just in this case, 7. I just chose a random prime number. And we have an exponent here that has a function of x. So let's take that derivative. So first we want to copy the original function. Let's get that exponent there, x squared plus 3x plus 1. Multiply that by the derivative of the exponent, which is 2x plus 3. And then adjust for the fact that the base is not e by putting a ln of 7. And that's the final answer for that example. In this next example, we have an exponential within an exponential. So we can apply the same strategies as before, perhaps with a little bit more care in terms of the nested exponentials. Let's focus on the 2 to the power of 3 to the x plus 1. We simply just copy that function. That is the exponential there. And then what we would do is multiply by the derivative of the exponent, and then finish by multiplying by ln 2. So now comes the bracket. In the bracket, we need the derivative of 3 to the x plus 1. We can do that as we have done in an earlier example by taking the derivative of 3 to the x, which is to copy it, and multiply by ln 3. The derivative of 1 is 0, so you have plus 0, but I'll just not put the 0. That's the final answer. Let's do one final example, which involves a quotient rule and exponentials. Now, looking at this example, you get intimidated with all the e to the x's. But if we just follow the quotient rule, as we've been using several times in the past, including in a video dedicated to the quotient rule, we start by taking the derivative of the numerator, so the derivative of e to the x, which is of course just e to the x, and then we copy the denominator, so that'd be e to the x plus 3, and then we copy the numerator and take the derivative of the denominator, which is e to the x, plus the derivative of 3, which is 0, over the denominator squared. Now, if you notice on the numerator, there is a common factor there of e to the x. So what I might do here is just take out the e to the x, put a square bracket, and maybe it makes it a little bit easier to follow. Within the square bracket, you see that this e to the x and that e to the x, they cancel. So this allows us to just take it a little bit further by writing a 3 here. So that's the final answer. Now, you could put the 3 there, or you could put the 3 here. I'm going to put the 3 in front of the e to the x, and there you have the final answer. So hopefully this was a good practice for you, and we can move on to the next video.